Hello everyone, welcome to Finite Element Analysis Laboratory by Youni-Learning episode 12. Today we are going to perform a 3D thermal analysis on a subscribe the channel for more updates. Let's continue. Our objective is to understand how the temperature distribution can occur on a 3D specimen and determine the thermal heat flux. We will perform an analytical study and a finite element analysis study on this specimen. The specimen in today's session is rectangular plate, which is in a 3D specimen. We will perform the analytical solution, which is the actual results, and compare it with the finite element method results accordingly. Let's discuss about the specimen dimensions and the material properties that it includes. This is our specimen. The plate is made up of steel having thermal conductivity 60.5 watt per meter degree Celsius. The dimensions of plate are 1 meter by 1 meter having thickness 0.25, which means that this is our 0.25 thickness and the rest is 1 by 1. First, we will perform the analytical solution. For this purpose, we will estimate the amount of heat flux that can be transferred from the lower point of heat to higher point depending upon the direction of heat flow. We will utilize the law of heat of conduction, which is through a uniform plate because our cross section is 1 meter by 1 meter. So we will utilize this formula where Q is the heat flow, K is the thermal conductivity, A is the area, and delta T is the change in temperature, and dx is the thickness of the plate, where K is the thermal conductivity and other parameters remain same. We will substitute these values in this equation and will determine these answers. The value of heat flow is 18876, which we found through analytical solution using law of heat conduction. We will form this type of table in which we have the serial number in column 1. In column 2 we have the quantities that we are trying to determine, the units, and the theoretical method results that we have previously calculated. We only calculated the conduction of heat flux, which is 18876 through theoretical method. We will determine this value through finite element method and will compare these values. Our last comments will be on the value of calculating the error, which is between this value and this value, FEA and analytical solution, and we will verify the law of conservation of energy for a 3D specimen, which states that energy can neither be created nor be destroyed but can transform from one form to another form. We will create this type of graph within ANSYS. Let's go to the ANSYS software. Kindly open the ANSYS Workbench software and go into the Analysis System column and double click on the Steady State Thermal, the analysis that we are trying to conduct for a rectangular specimen oriented 3D. Now we will name this analysis system to be 3D Thermal Analysis. Press enter. Now go into the engineering data properties so that we can define multiple materials for this analysis. Double click on the engineering data tab. It will open up the ANSYS built-in material library, in which by default structural steel is selected as shown. When you click on it, it will show its properties in which the isotropic thermal conductivity is 60.5 as we have specified in the presentation. Now we will click here on the engineering data sources to open up the ANSYS material library and select the material category to be general materials. It will refresh this outline of general materials. We will select titanium by clicking this plus sign, and we will also select stainless steel, and last one is the copper alloy. After selecting these materials, kindly click here on the engineering data sources again to close this library. And now we can see all the 4 materials that we have added. After adding these materials, kindly close the engineering data tab from here and right click on the geometry. Do not double click, right click only. One time right click and it will open up the menu in which you have to select the new design modeler geometry. It is the ANSYS built-in CAD software for the modeling of geometry. On the bottom left corner you can see that ANSYS is starting new design modeler for creating the CAD drawing. We will continue as soon as the design modeler starts. It is as you can see, the new design modeler window has been opened. Kindly go into the concept and select cross section to be rectangular because it is a rectangular plate. After selecting this cross section, kindly enter the value of B and H to be 1 meter by 1 meter and press enter. After creating this cross section, as you can see, this is our cross section rectangular. Kindly click on the RECT1. If you cannot see this option, kindly go into the cross section, click here this plus sign again, and it will open up the rectangular cross section. Now click on the extrude button. It will ask you to select the geometry that you want to extrude. Kindly click here on this RECT1 and click apply. After applying, enter the FD1 depth to be 0.25 meters. Okay, you have to enter a depth of 0.25 meters and press generate button. When you press generate button, you can see that at the origin a rectangular plate has been created. So far our geometry has been completed. Kindly close the design modeler window and go to the ANSYS Workbench window and double click on the model tab to open up the ANSYS mechanical module, in which we will specify 3 things: mesh size, boundary conditions, and the results that we want to achieve through this simulation. It is starting the ANSYS mechanical window. As soon as it opens up, we will continue. Now it is loading the geometry that we have created in the previous step. As you can see, the geometry has been extracted successfully. Now what you have to do, kindly go into the outline window and right click on the mesh and press generate mesh. It will divide this whole body into a finite number of elements like this. Each element is a cubic element. If you want to change the geometry material that we have assigned, you can kindly go into the geometry tab, click the plus sign and you select solid. After selecting this solid button, you can see that material assignment is by default structural steel. It has also all the materials that we have added previously, but for the sake of this analysis we will select the default option, which is structural steel. Now we will apply the boundary conditions. Right click on the steady state thermal, go to insert and select temperature. In order to select the geometry, use the selection cubes that are available in your ANSYS. In previous versions you can find these cubes at this position. Kindly go into one of these cubes and select the face selection cube and select this face and click apply. Let the magnitude be 22 degrees Celsius for this surface. Similarly, rotate the body, go into the steady state thermal, right click again, go to insert and select temperature again, and this time select this surface and click apply. Enter a magnitude of 100 degrees Celsius. These are all the boundary conditions that we have previously assigned in the analytical portion. After defining these boundary conditions, kindly go into the solution and right click, go to insert and select thermal and click temperature. It will show us the temperature distribution. Similarly, for the purpose of comparing the analytical with finite element results, kindly right click on the solution, go to insert, thermal and select total heat flux. Now after defining all of these, the last solution that we want to achieve is to plot a graph within ANSYS for this thickness value against the temperature. For this purpose, kindly go into the model, right click, insert, construction geometry and select path. If you are not seeing this path option here, kindly click on the construction geometry. When you click on the construction geometry, it will create a tab like this. Right click on it, go to insert and it will show you the path option. For my version of ANSYS, the path option is predefinedly added, so I will only change the coordinates of this path, the starting point of which will be x0 y0, which is this midpoint of the plate, and the z coordinate will be 0.25 meters, which is like this. The end point will be the origin. Now kindly rotate the body. As you can see that this line has been created along the thickness. So I will go into the isometric view by clicking on this ball, and now we will enter the results which we want to achieve against this thickness. For this purpose, kindly go into the solution, right click, click insert, thermal and select temperature again. Rename it to temperature along Z axis. After doing so, kindly go into the scoping method, change the geometric selection to path. When you select the path, it will ask you which path you want to assign. So we will scroll down and select the path that we have previously created, which is this one, from point 1 to point 2. After doing so, all of the results have been added. Kindly solve the model. solve the model to obtain the results. Now, as you can see, the model has been successfully solved. Kindly click on the temperature tab, and as you can see, the boundary condition the states the temperature distribution which occurs along the thickness. Similarly, calculate the total heat flux, which is 18876. We have to compare it with the analytical results. Now select the temperature along z-axis. It is showing you the temperature distribution along z-axis, the graph of which is shown below. When you move this tab above, you can see the temperature distribution along this thickness of 0 to 0.25, and y-axis is the temperature distribution. Now our analysis has been completed for the structural steel. If you want to change the material, kindly go into the general materials geometry tab and change the material. As our analysis has been completed, kindly close this window and save the project by going into the file, save as, and go in the directory where you want to save your model. Let's suppose I want to save my model here, which is episode 12. I will name it to be 3D thermal episode 12. The project is being saved. Congratulations, we have successfully solved the model. Now go into the file and select the archive button. This will create a single independent file which can be transferred, which can be mailed or can be WhatsApped. So kindly save this model in your required directory. Checkbox all these and click archive. Our project has been successfully completed. Thank you very much. If you have any questions, you can comment below. Kindly subscribe the channel for more recent update. Thank you.